Okay. So problem number 104, inverse functions, and this is the problem from version 4. Okay, we have this set of x and y coordinates. You can read the problem and see where they're given. We've got the 4x4 rectangle with the red dot at the middle. And we want to label the construction lines. So I've already labeled y equals -2 and y equals 2, because here's for y equals 0, this being the origin, the x-axis is y equals 0, so I've indicated that is the x-axis. Okay, implicitly is the x-axis. This is implicitly the y-axis. I've labeled it as the y-axis, so labeling could be confused. You simply need to know that these are the x and y axes, and with the arrows and the ends, it should be obvious that that's what they are. Now, it's a 4x4 rectangle. So it's 4 units here. You have symmetry, so you got 2 units on this side, 2 units on this side. This is x equals 2. This is x equals negative. These 2 vertical lines. The 2 horizontal lines that go through the boundary are y equals 2, y equals -2. We easily label the lines halfway between the middle and the halfway between the upper edge and the middle horizontal line. The one halfway between, of course, is halfway between 0 and 1, so it's y equals 1. And then the one halfway between y equals 1 and y equals 0 is obviously y equals 1/2. Okay, then halfway between y equals -2 and y equals 1, it's this line. It's y equals -1. And here it's y equals -1/2. Similarly, we label this line x equals 1. This line, I'm sorry, x equals -1. This line x equals 1. On this line, x equals -1/2. This x equals 1/2. So now we kind of know where everything is. Okay. So now we can plot these points. Now I gave you the points in order of pair. It should be obvious how the order of pair relates to the table. Okay, so we have -1.6, -1.6. Well, here's -1, here's -2, -1.6 is going to be a little closer to -2 than it is to -1. It's probably getting closer to -1.7 over here. But then -1.6 on the x-axis will be closer to x equals -1 than it is to x equals -2 than it is to x equals -1. So they get to be here. Now this graph is particularly well constructed. This is supposed to be halfway between here and here, and it's well short of halfway. So we've got some inaccuracy here, but that's kind of okay. But try to do a little better tonight. Okay, then we have -0.7, -0.03. Now that's okay, that's y equals 1, -1.6. This is x equals -1.6. Then -0.7, -0.3. -0.7 is between 1/2 and 1 between -0.5 and -1. So it's going to be about here. And sorry, that's supposed to be x equals -0.7. That's going to be between x equals 1/2, -1/2, x equals -1. So it's going to be about here. It's hard to label it. X equals -0.7. That's going to be this. X equals -1 is slide. It can get a little cumbersome. Marking all the points. Anyhow, -0.07 and the y coordinate should be -0.03. So there's -1/2, which is -0.5. There's 0. It's going to be a little closer. -0.5. They did a real good job with that one either. But those two lines, x equals -0.7 and y equals -0.3. Kind of join about there. Then 0.7, so I'm just going to mark that. X is 0.7 on a line that goes about here. Y is 0.7 on a line that goes about here. So that puts you at a point It's about here, then 1.5, 1.3, x is 1.5, that would be about here. And 1.3 would be about here, so it's gonna be something like this. Now we're supposed to draw a smooth curve through these points. So I can do that, go through this point. I'm gonna have to turn to get through this point, then probably go concave up again. So the curve might look something like this. Your curve might look a little different, but it's not going to be a straight line from here to here, and then a straight line from here to here. You'd have a corner right here. It's not smooth. Okay. Want to make sure it's a smooth curve. So here's the curve y equals f of x. Then you're asked to, well, let's see, how do we state it? Make a table for the function f inverse of x. Okay, well, the easiest way to make a table for the f inverse is to switch the x and y columns. So the y column is negative 1.6, negative 0.3, 0.7, 1.3. So I'm just going to copy those numbers down. The x column. And then copy out these numbers in the x column down to call it y column. And now I can plot these points. I'm not going to go into all the detail of plotting the points, except to say that, well, negative 1.6, negative 1.6 is the same as on this graph. Okay, so I'm going to put an X here as well to indicate both point on function f of x graph and the graph of f inverse of x. Then negative 0.3, 0.7, well, negative 0.3 would be about here, negative 7 about here. So let's make this purely blue. Okay, there's a point. Then 0.7, 0.7. Well, looks like we're back on our original curve. But then 1.3, 1.5, now 1.3 is a little bit to the left of the midpoint, the line halfway between these two. And 1.5 is halfway between these two. So that's going to give me a point about here. Something like that. Okay. And now we can draw a smooth curve for the inverse function. So I'm going to go through here, come back up here, then go through here. Okay, so it looks like this graph kind of winds around this graph. Now that won't always happen. We've seen plenty of graphs of inverse functions, but this is what it would look like for this function. So reasonably facsimile of this. So we want to estimate f inverse of x for x equals 1.6. Well, I am going to draw the projection lines. Say this is x equals 1.6. I think I've got it maybe a little too far to the right, but it's the right ballpark. And then we want to draw a horizontal line through the point where this curve meets this line x equals 1.6. So according to this point, let's just make a table. Now this blue graph is a graph of f inverse of x. When x is 1.6, f of x, obviously blue for f of x, looks like it's way up here, 2.8 or 2.9. I'll say maybe 2.9. 2.8 would be an equally good estimate. Okay. And it's not 2.9, it's 1.9. All right. Then we want to estimate, we want to call this S. We'll say S is 1.9. So we probably want to write this out just to reinforce yourself what we mean by call this number S. Okay. Then we want to find f of S. What is f of S equal? Well, f of S is then f of 1.9. Okay. Now, f of 1.9, let's get a different color here. Okay, x equals 1.9 is about here. And it isn't clear exactly what f is going to do after this point. It's the way I've drawn it, it's tending to curve somewhat downward. Or maybe it's going to continue to curve downward. So if f of x curves upward, that's not quite accurate. Still, we're going to make the best of this. So it looks like f of 1.9 might equal about 1.9. That was the point where this curve reaches about here. Okay. That's quite work out. And one of the problems is, well, don't worry about it, just do what it says. Okay. I'll get to the last question here. Let's say this is about 1.9. You may even estimate that it's 2. Then we want to estimate f of 0.8. So that if x equals 0.8, you're going to be on, let's say, this line. I haven't drawn that quite right. Here's x equals 0.8. And we meet the line here so that f of 0.8 looks like it's about 1. We're going to say, okay, I'm going to make a table here because I anticipated that I would need to, but I wasn't anticipating correctly. So I'll get rid of that. This is a short table. Okay, so I'm going to do x equals 0.8, f of x appears to equal about 1. Now we're going to call that value r. So that r equals f of 1, which is 1. So what's f inverse of r? Well, let's let x equal 1 and see what f inverse gives us. Oh man, I estimated f inverse of 1 with this this point should have been on the function, on the curve of the function L. Okay, so I'm a little mistake here. Right here, we get y equals about 0.7 from this one. So that this value should have been 0.7. So that f of 0.8, I wrote down where this likely says e. Say that f of 0.8 is 0.7. F inverse of r would be f inverse of 0.7, which we can find on the f inverse graph. By going to 0.7, which would be about here. And we get a point on the graph of f inverse, and we might estimate that according to the graph, f inverse is 0.7, pretty close to 1. So I'll say that's maybe 0.8. That might be a little hard to see. These things are kind of cluttered up here, and don't particularly like the way I generated the numbers of this function. So kind of a hard function to see. This is how we do. Get R, we do f of 0.8. So we go to 0.8, see where we hit the f function. It turns out to be about y equals 0.7. And then we do f inverse of 0.7. And it looks like we get a little higher. We get like 0.8. Now, what should ideally happen is you know that you compose a function with its inverse, you're supposed to get x. Okay. Now, we replace x by s. F of s equals f of f inverse of our original x, which is 1.6. Supposed to equal x. F inverse of 1.6 is 1.9. And f of 1.9, we estimated to be about 1.9. I'm afraid this isn't as clear as I'd like it to be. And the problem is just that these two graphs are kind of too close together to really see what the relationships are. It's a good chance that I'm going to revise this problem. So I'm going to leave it at this for right now. Probably revise the problem and do a video with a revised problem where these two graphs don't weave around each other so that the estimation problem becomes just hard to see. Okay. So the numbers in this problem right now don't work out too well. So I think I'm gonna, I might not even post this video, but if I do, it'll be with a warning.